So this is a very brief look at how much throwing hardware at the problem, increasing your parallelism for the upgrade, will improve your performance and reduce your downtime. So here's the benchmark situation. We have a bare metal system with 36 OCPUs, so that's essentially 36 hyper-threaded cores there. We're going from 11204 to 19C with a full complement of components in the dictionary. And what we'll see is that if you just use a serial upgrade, parallel equal 1, then this database will take 48 minutes to upgrade. And that means with recompilation, that might be upwards of an hour. To reduce that time, we can increase the parallelism. Parallel 2 will upgrade in just over half an hour, and then parallel 4, which is the default for upgrade, will get you upgraded in about 25 minutes. So you might ask, why did we make parallel 4 the default? And you can see the answer here is that by going from parallel equal 4 to 8, doubling the number of processes and the resources used, we're only saving about 2 minutes for this particular upgrade. If you extend this out to, say, a container database with lots of pluggable databases, well, in that kind of environment, the default parallelism per PDB is 2. And you can see why. The curve flattens out from 1 to 2 to 4. And past 4, it really doesn't provide that much benefit for additional parallelism. The reasons for this are twofold. One is dictionary contention on those objects that we might be updating or accessing. And two is that there are still some aspects of the upgrade that are serialized, that they have dependency ordering and they can't do everything in parallel. So this is why we've chosen parallel 4 as our default and why the maximum is 8. And also why in a container database, the parallelism default for each pluggable database is 2. Now I'll turn you back over to Rodrigo, and he'll talk about the number one way that you can improve the performance of your database upgrade for an individual database.